Morning friends. In this video we are going to see about normalization methods using Python. So here normalization actually we have three different types: min-max normalization, z-score normalization, and normalization by decimal scaling. So what is min-max normalization? So here this method we will use when we are transforming a or when we are scaling a value from original set of bounds to new range, from original range to new range. If you are scaling any value, then you need to go for min max normalization. So here the formula is v dash equal to p minus min a by max a minus min a into new max a minus new min a plus new min a. So here v is the value that which you are going to scale into the new range. V is the value which you are going to scale into the new range. Min A and max A are the original bounds, original range. In the original range, the minimum value and the maximum value, right? That is from the original range. New max A, new min A. This is the new range. In the new range, the minimum value new min A, maximum value new max A. Okay. So here the value you are scaling into the new range is V. The obtained value after scaling is represented with V dash. Okay. So when the original range and the new range are known to you, you can go for min-max normalization scaling. First thing. Second one, z-score normalization. Here the formula is V dash equal to V minus mu A by standard deviation of A. So here V is the value you are going to scale, right? Then mu A, it is the mean value of attribute A. It is the mean value of attribute A. Sigma A, it is the standard deviation of attribute A. So the value which you are scaling, which are going to scale in is V. And once if you can calculate the mean and standard deviation of that attribute, you can go for z-score normalization. And the third one is by decimal scaling. The value which you are going to convert it into the decimal is decimal scaling. V is the value you are going to scale, and 10 to the power of j, where j value is the any smallest integer possible. Here if you can take j value as 1, 2, 3 and so on. So you can notice the decimal value accordingly, right? So here min-max normalization, z-score normalization, and normalization by decimal scaling, right? Now we will see z-score normalization implementation on a simple data frame, right? Now consider this data frame. Yeah. Here is the data frame we considered. So import pandas, then create a data frame. So df is equal to, and if you check the data frame, how many values are here, right? One particular row, second one, third one, and then the fourth one, right? Now, how many rows we got? Four rows of data. How many columns we got? One, two, three, four, right? 1,80,000, 110, 18.9, 1400. Similarly, in the remaining also. So here we are having four columns, and the column names are we considered here as column A, column B, column C, and column D. This is the data frame we considered. So to display this data frame like this, you will get column A, column B, column C, column D, right? So on this data frame, we are going to apply scaling, normalization. So using z-score normalization, what we are going to do. In the previous formula, I mentioned about a particular value. Now in this case, all the values we are going to all the values all the values in the data frame we are going to scale using z-score normalization. So how can we access it? All the elements, right? So now we will see that code. Yeah. So first part here is you need to copy you need to copy the data frame into the new variable df underscore z underscore scaled I have taken here. So next, apply normalization technique. So first thing what I mentioned, we are going to apply normalization not on a single value, all the elements in the data frame. So all the elements means all the columns you need to access. All the columns you need to access. So for that iteration, I have mentioned for loop. So for column in df underscore z underscore scaled dot columns. Like how we will mention df dot columns. Df dot columns gives you the value, all the columns, all the attribute names or all the column headings mm, in the data frame, right? So here I have considered df underscore z underscore scaled dot columns. So whatever the data frame you have copied in that data frame, all the columns it will consider. So each column it will iterate. So df underscore z underscore scaled of column is equal to. Now what I have taken here, each column, suppose the first column you consider, for a column, first iteration if we take, it will consider the first column, right? All the elements minus, what is the actual formula? Mu a at mean value of attribute a. So that particular column, mean value by, what about the remaining? By standard deviation. So that particular column here dot standard deviation, right? This is for one particular column and the next iteration it will progress. Okay. So like this, all the columns, the iteration will be processed and finally the result will be displayed. So df underscore z underscore scaled, that result will be displayed, right? So again I'll repeat what I have considered here. What is the actual formula? V minus mu a by standard deviation of a. That means V is the value we are going to scale minus mu a, mean value of attribute a by standard deviation. So the same thing we applied here for column wise iteration. So this particular column minus its mean value. So mean function we have written. Its mean value by standard deviation. STD represents standard deviation. So once if you run this code, let us see the output, right? All the values we got after scaling. Okay. What is the method we applied here? We performed this for z-score normalization. So 4 columns, each column iteration is completed and this is the result. Now, if you are notice the values, few are negative, few are positive, right? So minus 0 point here 1 point. So all the values, including 0.0000 also. So how to plot this graph? Okay, so to plot the graph, we need matplotlib to import. So here, these are the two lines, simple two lines to give you the bar graph. So import matplotlib.pyplot as PLT because you are going to plot the z-score normalization result. So where it is stored? It is stored in, the result is stored in df underscore z underscore scaled, df underscore z underscore scaled dot plot. So what type of plot you are going to use? Kind equal to bar. So here you will get the bar graph. Here you will get the bar graph for all the columns A, B, C, D. Right. Now if you see the graph, uh, once if you see the graph, you can understand what exactly it is, how it is shown. right? So now you check this one. Here we have four columns. So color nomination is there for each column. So for each column, it is displayed. So that is why four variations, right? So this is the graph plotted, and we have some negative values and we have some positive values also, right? So for one particular value, we have 0.0000 also. So that is the value here. Here you can notice only three bars, right? The fourth one value 0.000. It simply doesn't appear, but its value is 0.000. So that's why it is marked on this line. The remaining values you can observe, right? So the simple steps what we followed, we have taken a data frame, then we have applied the same formula with for loop iterations, then we have plotted it. So simple. Now we applied z-score normalization. Similarly, you can try for min-max normalization using this formula. When you are given with new range, then you can use this formula directly. If not, if the new range is not yet provided, then use the formula v dash equal to v minus min a by max a minus min a. The new range is not provided to you, v dash equal to v minus min a by max a minus min a. Then observe the result. Observe the result. You'll be surprised. And the decimal scaling, you can, it's a so simple formula. You can apply directly. So that score normalization, whatever the steps we followed, the data frame, then applying this formula with for loop iterations, then plotting it. The same three steps you can apply for min max normalization and decimal scaling also. So this is how you need to go for normalization, three approaches, right? Hope you understand. Thank you.